All right, today we're jumping right into a cosmic detective story, one that's all about our own home, the Milky Way. So let's get right to the central mystery. What bent our galaxy? I mean, it's a simple question, but it's totally baffling. See, the Milky Way, it isn't flat. For decades, astronomers have been scratching their heads trying to figure out what kind of cosmic force could be powerful enough to warp it. But now, a surprising new witness has just come forward, and its testimony, well, it's about to change the entire investigation.
Okay, so this isn't exactly brand new information. We've actually known since the 1950s that the edges of our galaxy are bent. The best way to picture it is like a vinyl record that's been left out in the sun a little too long. It's warped. And let me be clear, this isn't just some tiny little quirk. We're talking about a massive galaxy-spanning feature of our home. So you gotta ask, right? What in the universe could be powerful enough to do that to an entire galaxy? Well, the detectives have a couple of main suspects. Theory number one. A violent collision. Maybe a smaller galaxy came crashing through ours a long time ago. Or is it something else? Something a little less dramatic but just as powerful?
So how do you solve a case like this? Well, astronomers basically become forensic investigators. They start interviewing the stars. And I mean that quite literally. Different groups of stars are their key witnesses. And by looking really closely at how stars of different ages are moving around, they can start to piece together a timeline, a sequence of events for our galaxy's history. And this is where a star's age becomes the absolute key to cracking the case. Think about it. If a smaller galaxy came punching through the Milky Way, its gravity would have yanked on everything. Old stars, young stars, it wouldn't matter. They'd all get bent out of shape. But what if the warp is being caused by new gas flowing into the galaxy? In that case, only the brand new young stars born from that gas would show the warp. See the difference? It's a critical clue. Okay, so we already had testimony from the young stars. We knew they followed the warp. But that's not enough to solve it. To really put that collision theory to the test, astronomers needed to talk to a much older witness. And for that, they turned to a very special kind of star. It's called an RR Lyrae. And for a long, long time, these stars have been considered the classic go-to witnesses for the most ancient events in our galaxy. So why these stars? What makes them so special? Well, they're invaluable because they are what astronomers call standard candles. Imagine a cosmic lighthouse. You know exactly how bright its bulb is. So, just by seeing how dim it looks from far away, you can calculate its exact distance. That's what these stars are. They're a cosmic measuring tape, and they let us map out the galaxy's structure with incredible precision, especially way out on those warped edges. But of course, there's a catch. There's always a catch, right? The problem is, our key witnesses are hiding in a crowd. They're all mixed in with a bunch of lookalikes from what's called the galactic halo. That's this giant, spherical cloud of stars that surrounds the main disk, but, and this is key, it doesn't rotate along with it. So the first job for our detectives was a big one. How do you find the real witnesses, the ones that are actually part of that spinning, warped disk? All right, so let's get into how the team actually did this. It's a really clever bit of detective work. What they did was basically sort the stars by how they move. It's kind of brilliant. Just picture it. The stars in the galactic disk are all zooming along together, rotating around the center of the galaxy like cars on a racetrack. But the halo stars, they're all over the place, moving randomly, kind of like bees buzzing around a hive. So if you can measure how fast each star is moving and in what direction, you can pretty easily tell who's on the racetrack and who's just buzzing around. And when they looked at the data from the Gaia Space Telescope, boom, a super clear separation. You've got one group of stars, the halo stars, kind of puttering along with slow random movements, and then you've got another group, the disk stars, just flying by at high speed. The researchers drew a line in the sand. Any of these RR Lyrae stars moving faster than 170 kilometers per second, that's our guy. That's a disk star. So after all that meticulous filtering, the team finally had what they needed, a pure sample. 321 key witnesses, all confirmed members of the Milky Way's disk, ready to testify about the galaxy's great warp. Okay, so they have their witnesses, but when they started analyzing the testimony from these 321 stars, things got weird. They found not one, but two huge surprises, a couple of twists in the tale that were about to change the entire direction of this investigation. So the first surprise came when they answered that one critical question we started with. Do these supposedly ancient stars actually follow the warp? This was a huge deal because it had never, ever been confirmed before. And the answer was a resounding, definitive yes. For the first time ever, it was proven. These older stars trace the warp perfectly, moving up and down right along with all the younger stars in the disk. Now, that alone was a massive discovery, a really powerful piece of evidence that pointed right at the cosmic collision theory.
But then came the second surprise. And this was the real plot twist, the one that completely upended decades of what astronomers thought they knew. See, when the team looked closer at how these stars were moving, something was off. Their orbits were, well, they were too clean, too orderly. A truly ancient star, one that's been around for 10 billion years, should have a messy, chaotic orbit from getting knocked around by gravity for eons. These stars, they were just moving too calmly. It turns out they weren't ancient witnesses at all. Their calm, orderly movement was a dead giveaway. They belonged to a completely unexpected intermediate-age population, only about 3 or 4 billion years old. Get this, the key witnesses in the case, the ones everyone thought were the old-timers, were actually from a totally different, much younger generation than anyone ever suspected. So, what does that mean for the original mystery? This shocking testimony just threw a huge wrench in the works. What does it tell us about what bent our galaxy?
Well, for starters, the case is definitely not closed. But what this discovery has done is give us a powerful new lead. We now have an entirely new tool in our toolkit, an intermediate-age standard candle. This allows us to map the warp with insane precision, and it lets us probe a whole chapter of our galaxy's history that was basically invisible to us before. And that really is the heart of it, isn't it? Why this matters. It's not just about the warp anymore. By questioning a simple, long-held assumption, the age of these stars, these astronomers unlocked a brand new way to investigate the entire history of the Milky Way. It's a whole new window into our own cosmic backyard.
You know, this whole breakthrough happened just because someone decided to take a closer look at stars we thought we had all figured out. And that just leaves you wondering, right? What other huge, profound cosmic secrets are hiding out there in plain sight, just waiting for us to ask the right questions and challenge what we think we already know?